Voltage, vitality, elevation.
It came out of the darkness, a traveler from a place beyond our sun's embrace. So, this cosmic visitor was not formed in our solar system. It is a true alien, in the most literal sense of the word. The main myth we must immediately bust is that this object posed any threat to our world. It did not. It was a guest, not an invader, passing through our celestial neighborhood at a vast and safe distance. The story begins on July 1st, 2025, when sharp-eyed astronomers using the Atlas Survey telescope in Chile first noticed a faint smudge of light moving against the backdrop of distant stars. This was not just another rock from our own asteroid belt or a familiar comet from the Oort cloud. This was something different, something special. The object was quickly designated 3I Atlas, a name that packs a universe of meaning into a few characters. The I stands for Interstellar, a label reserved for the rarest of celestial sightings. This confirmed it as only the third such object ever detected by humanity, following the enigmatic Oumuamua in 2017 and the more conventional comet 2I Borisov in 2019. Each of these interstellar objects is a precious, fleeting messenger, carrying physical clues about the conditions and chemistry of star systems that lie light years away. Imagine standing on a remote island, having never seen a boat from another land. Then one day, a piece of driftwood washes ashore, carved in a style you have never witnessed. That piece of wood tells you something profound. There are other shores, other forests, and other hands at work across the sea. What exactly makes an object interstellar? It all comes down to its trajectory, the path it carves through space. Objects formed within our solar system, like planets and our local comets, travel in closed elliptical orbits around the sun. They are bound by the sun's gravity, destined to repeat their journeys over and over. But 3I Atlas is different. It is moving on a hyperbolic path, an open-ended trajectory that proves it is not gravitationally bound to our star. Think of it like a stone skipping across the surface of a pond. The sun's gravity acts like a small dimple in the water, bending the stone's path slightly, but the stone has far too much speed to get trapped. It will curve around the sun and then shoot back out into the void, never to return. This visitor's schedule was a major focus for astronomers around the globe. After its discovery on July 1st, 2025, observatories scrambled to track its journey. The key date was October 30th, 2025, when 3I Atlas reached perihelion, its closest point to the sun. At this moment, it was subjected to the most intense solar radiation and heat, causing it to brighten and release a torrent of gas and dust. Following its solar encounter, the object began its outward journey, offering another window for observation. Its closest approach to Earth occurred on December 19th, 2025, but, well, close is a relative term in space. On that date, 3I Atlas was approximately 1.8 astronomical units away from us. 1 astronomical unit is the average distance from the Earth to the Sun, about 93 million miles or 150 million kilometers. So, at its nearest, this interstellar object was 1.8 times farther from us than the Sun is, significantly farther away than Mars at its closest approach. One of the first questions astronomers ask about any new object is simple. How big is it? For a distant, fuzzy object like a comet, this is surprisingly difficult to answer. The bright cloud of gas and dust that surrounds a comet, the coma, can be enormous, but it obscures the tiny solid nucleus hidden within. Scientists use sophisticated techniques. They analyze reflected sunlight and measure the amount of material being shed to estimate the core's size. For 3I Atlas, the estimates vary, but all point to a substantial object. The nucleus is thought to be about a few hundred meters up to a few kilometers in diameter. A few hundred meters across, about the size of a large sports stadium or a monumental skyscraper. A few kilometers, the size of a small town or a respectable mountain. This solid body of ice, rock, and dust is the heart of the comet, the source of its spectacular activity. The nucleus size determines the comet's reservoir of volatile materials. These ices will turn to gas, creating the coma and the tails as it nears the sun. Size also affects the comet's origin story. A larger nucleus suggests a protoplanetary disk rich in building materials. It might hint at a star system similar to our own, or one even more abundant in comet-forming ices. As 3I Atlas traveled, its brightness fluctuated, changes from rotation, active regions, and sudden outbursts, letting scientists map active zones and estimate rotation. It's like understanding an unseen island by watching smoke from its volcanoes. A monumental challenge, but one that yields incredible insights. While 3I Atlas shared some characteristics with the comets from our own solar system, it also displayed some truly strange behaviors. One of the most striking features was its prominent anti-tail. Most people picture a comet with a single beautiful tail of dust and gas streaming directly away from the sun, pushed by solar wind and radiation pressure. An anti-tail, however, is a feature that appears to point towards the sun, seemingly defying the laws of physics. In reality, it is an optical illusion, one that tells a fascinating story about the comet's composition and our viewing angle. This ghostly spike of light is composed of larger, heavier dust particles not easily blown away by solar radiation. These particles are left behind in the comet's orbital path. When Earth's position is just right, that trail looks like a spike pointing sunward. The anti-tail of 3I Atlas was exceptionally long, stretching some 400,000 kilometers, greater than the Earth-Moon distance. This strongly implies 3I Atlas shed many large pebble-sized grains, not just fine powder, and hints at differences in how it's held together or formed. Adding to the mystery were the wobbling jets of gas and dust erupting from the nucleus. As a comet heats up, ices on its surface turn directly into gas in a process called sublimation, shooting out into space and carrying dust along for the ride. With 3I Atlas, these jets appeared to wobble or precess. This motion suggests the nucleus is rotating, and the jets are not aligned with its spin axis. This complex behavior helps scientists model the comet's rotation, shape, and the rugged, uneven nature of its surface. When astronomers pointed their spectrographs at 3I Atlas, they were not just taking a picture. They were decoding a chemical message from across the galaxy. The light from the comet was split into its constituent colors, revealing a rainbow spectrum crossed by dark and bright lines. These lines are the chemical fingerprints of the molecules present in the comet's coma. One of the most visually stunning discoveries was the distinct green glow emanating from the cloud of gas surrounding the nucleus. The green hue is primarily caused by dicarbon C2 and cyanide, CN, simple molecules common in comets of our own solar system. When released and exposed to harsh ultraviolet sunlight, they become energized and radiate that energy as green light. While the word cyanide might sound alarming, its presence in comets is normal and poses no threat, spread incredibly thin through vast space. Observations hinted at methanol and significant carbon dioxide, CO2, far more volatile than water ice and able to sublimate in the cold, far from the sun. An abundance of CO2 could explain why 3I Atlas was so active and helped account for jets that nudged its path. These non-gravitational forces can slightly alter a comet's path. Astronomers must account for them to plot precise trajectories. Each molecule detected is a piece of a larger puzzle. Water, carbon dioxide, carbon monoxide, methanol, and more. Their relative amounts tell us about temperatures and conditions where the comet formed. Cold outer reaches or closer in ejected by a giant planet. By comparing 3I Atlas to our comets and to planet formation models, scientists place this alien object into a broader cosmic context. So, why does a single, fleeting visitor like 3I Atlas matter so much? Well, the importance of this object cannot be overstated. It represents a rare opportunity to perform direct reconnaissance of another solar system without leaving our own. First and foremost, 3I Atlas is a physical sample, a postcard delivered from an unknown star. The materials it is made of, ices, rocks, organic molecules, did not form around our sun. They formed in a protoplanetary disk around a different star. Studying its composition lets us test a fundamental question. Is our solar system typical or unique? 3I Atlas, with its unusual anti-tail and wobbling jets, provides a crucial external data point. From discovery, a worldwide network, professional observatories, and amateur astronomers sprang into action. Space agencies mobilized, NASA, ESA, retasking space telescopes and probes to gather precious data. This effort shows our growing ability to detect, track, and characterize transient celestial events. The comet is predicted to pass near Jupiter in early 2026. A close encounter could tweak its path or spark new outbursts, revealing more secrets. This collaborative chase is science at its finest. If its properties are wildly different, we may revise models and accept multiple pathways. If broadly similar, it supports that chemistry and physics operate uniformly across the galaxy. Whenever an object arrives with unusual characteristics, especially one from outside our solar system, it inevitably sparks a fascinating debate. For 3I Atlas, two main schools of thought quickly emerged. The overwhelming majority landed on a natural explanation. In this view, 3I Atlas is simply an interstellar comet, albeit a particularly interesting one. Its long anti-tail and precessing jets can be explained by viewing geometry, abundant large grains, and an irregular, rotating nucleus. By Occam's razor, the simplest explanation fitting the data is usually correct. Astronomers have seen anti-tails, jets, and rotation in many comets. Slight path deviations are readily explained by non-gravitational forces from powerful, asymmetric jets. A small but vocal minority, including figures like Avi Loeb, urged openness to technological origins, without claiming it is an alien probe. Due diligence followed. Projects like Breakthrough Listen scanned for technosignatures, structured or narrowband radio signals. The result was nada, no confirmed evidence of technology. Absence of evidence is not evidence of absence, but the lack of technosignatures strongly reinforces the natural explanation. Science follows the evidence, and it points to a fascinating natural comet. With an event as exciting and rare as an interstellar comet, misinformation arises. The first myth, impact threat, is unequivocally false. From the start, astronomers knew 3I Atlas would pass at an enormous distance, over 167 million miles, on December 19, 2025. There was never any risk of collision. The second myth concerned cyanide. The idea of poisonous fallout is science fiction. The detected cyanide is an incredibly diffuse gas in space. Even if Earth passed through a tail, which it did not, our dense atmosphere protects us. We are dust-bombarded daily without ill effect. The third myth, definitive proof of aliens. Without verifiable technosignatures or impossible maneuvers that remain speculation, not established fact. Busting myths doesn't diminish wonder. 3I Atlas is a magnificent natural wonder that gifted us knowledge. The truth is more than amazing enough. What happens now? As of January 28, 2026, 3I Atlas is already receding, its brief, fiery moment in the solar spotlight now fading as it journeys back into the cold, dark expanse. It will be tracked for months, perhaps years, until it becomes too faint to see. But terabytes of images, spectra, and orbital measurements will occupy astronomers for years, modeling behavior and refining chemistry. Its legacy sharpens planetary defense and rapid response astronomy, and nudges the dream of rapid launch interception toward engineering reality. For now, we remain shoreline observers, studying the messages that wash up from the cosmic sea. 3I Atlas reminded us the universe doesn't owe us familiarity. Every interstellar visitor is a cosmic postcard from distant worlds. Thanks so much for watching, and be sure to zap the like button and subscribe so you don't miss a thing. What do you think of 3i Atlas? Let me know in the comments. It's sure to be a fun conversation. Stay curious, guys, and always stay elevated.
Thanks for watching Voltage Vitality Elevation. Please select one of the videos displayed on the screen to continue watching.